Heyo! Welcome back. 4.7, we are going to be talking about equilateral triangles. Now let's just do a quick review of the three different kinds of triangles. We have iscalene, which is no congruent sides, and no congruent angles. Alright? None of these are the same. We have an isosceles, which remember is two congruent sides, and two congruent angles, and then you have the equilateral, which is three congruent sides, 1, 2, 3, and three congruent angles, 1, 2, 3. Now, today we're going to be discussing equilateral triangles, so let me just give you a little bit of information about them. The definition of an equilateral triangle is that it has three congruent sides and three congruent angles. Alright? Now, if you know that it is an equilateral triangle, if you see that it has three equal sides, then you know that all the angles are going to be equal to 60 degrees. In every single equilateral triangle, from now until the end of time, all three angles will be 60 degrees. Alright? All angle measures are 60 degrees. All sides are always congruent. All three of them will always be congruent. So if this was, say, 3, this side would be 3, and this bottom side would be 3. And equilateral triangles like pizza. It's a fact. With pepperonis. That's an actual fact. Believe it. It's a true one too. Oh, what is going on? So, let's do a few of these problems, just work through them. Triangle ABC is an equilateral triangle. Fill in the missing sides and angles. Well, let's see. We know that one of the sides is 10, and we know all three sides are congruent. So if one side is 10, then we know the other two sides are 10. And how do we find out the angles? Well, they are always 60 degrees. Boom! That was easy. So in this triangle, we know DE is congruent to EF, which is congruent to FD. Three congruent sides means it is an equilateral. Now, I want to solve for X. Well, what we know is that since all the sides are congruent, I can set them equal to each other. So I know that 13x plus 5 is equal to 9x plus 69. Now I'm trying to find what value of x makes these the same. So, put a line down the middle. Let's subtract 9x from both sides. Okay. When we do that, we get 4x plus 5 equals 69. Subtract 5 from both sides. That cancels. We get 4x is equal to 64. Divide both sides by 4. We get x is equal to 16. Now, did we even do that right? Well, if you plug in 16 for x on both of these, you should get the same number. I suggest trying it to see if we even found the right number. Okay. Two more problems. Triangle ABC is an equilateral triangle. So that tells me that all the sides are congruent and all the angles will be 60. Find the measure of DBC. So D all the way up to BC. So we're trying to find this angle right here. Well, we're not given much information. We only know that this angle over here is 32 degrees. These aren't congruent because they didn't tell us that. But what we do know is that all the angles are going to be equal to 60. So this is going to be 60 degrees. This is going to be 60 degrees, right? And also, this one is going to be 60 degrees, the whole angle. So to solve for this missing part of the angle, remember the angle addition postulate? If I know this whole thing is 60 degrees, this whole angle, all I have to do to find the missing part of the angle is 60 minus 32, and that gives me 28 degrees. Boom! And doesn't that make sense? 32 plus 28 equals 60. Since this is equilateral, all three should be 60. Now finally, in the measures in degrees of three angles of a triangle are x, x plus 10, and 2x minus 6. The triangle must be what? Well, the way to do this is first to find out what x is. Alright? And the way to do that is, since we know this is a triangle, alright, we know these will all add up to 180. So remember, we can just set up our three blanks equals 180. So x plus 10 plus 2x minus 6 is equal to 180. what we're going to do is subtract 10 from both sides and add 6. That cancels, that cancels. And so what we get here is, let's bring it down, x plus 2x is equal to 176. Well, we can combine like terms here, x plus 2x, that's 4 x's, is equal to 176. Divide both sides by 4, and we get x is equal to 40. Let's see, I'm trying to do this in my head, 44. Now we're not done. That doesn't tell us what kind of triangle this is, okay? So what we have to do is find out what the 3 angles are. So we have x minus 10, and we have 2x minus 6. All right. Now we're going to plug in x for all of these. So we know x is just equal to 44. Okay, so that's our first angle. That's angle 1. Our second angle is going to be 44 minus 10, which is equal to 34. All right. That's our second angle. And our third angle is going to be 2x minus 6, which is 2 times 44 minus 6, which is 82. Now if I look at the 3 angles, all 3 are different, meaning there's no congruent ones, meaning my triangle is scalene. So once again, all you had to do was solve for x, and then plug in x for each of the angles, and see what kind of triangle it was. Scalene, no congruent sides. Equilateral, no congruent angles. Equilateral, 3 congruent angles, and isosceles, 2 congruent angles. And a right just means it has a 90-degree angle. All right, finally, construction, everyone's favorite. What we're going to be constructing is equilateral triangles, and there's 2 different ways we're going to do it today. So the first one we're going to do is on the line segment below, using this line segment, use a compass and a straightedge to construct an equilateral triangle. We'll call it ABC. So the way to do that is just take your compass and place it over the whole width, okay? Like we did with perpendicular bisectors. Place it over the whole width of the line. Now what you're going to do, just like with perpendicular bisectors, you're going to draw this whole upward part right here, okay? Like half a circle, all the way going through it. You're going to turn your compass around, all right, turn it over, and you're going to do it on the same side. So now we're moving our pen to the other side and our needle to the other. And we're going to go through and do the same exact thing. Boom. Now, if you look here, I'm going to move my thing. Right over here, you'll see that this length is the same length as over here. So if I drew a line from here to here, if I drew this line right here, I know that this line is the same length. Oh, go back on that. I know that this line is the same length as this line. These 2 lines are the same exact length. Now furthermore, I'm going to put it back over here just to show you. If this length also is the same length as this length as well. So if I drew a line from here to here, all right, if I drew a length from here to here, that would also be the same length. So basically, all you have to do, oh, let's move that again. All you have to do is draw these 2, what's called arcs that intersect, and then draw 2 lines from your original line to the point of intersection, and that will give your equilateral triangle. All right, rewatch that if you want to see it again. But all you have to do is draw a line, draw your 2 arcs, all right, using your compass, all right, and draw a line from your original line to that point of intersection on both sides, and that will give you an equilateral triangle. And we know that this side is equal to this side, which is equal to this side. And you know what? It's good to always label things. All right, for our second problem, using a compass and a straight edge, we're going to do something a little different. We're going to construct an equilateral triangles with all sides equal to AB, but it's not going to be on AB. We're just going to have all the sides equal to the length of AB. So really what you have to start by doing is just measuring how long AB is. And you might remember with a compass you can measure the length of something by just placing the compass from one end to the other. So we want each side to be this length. Alright, now what I want you to do is just put a point on your paper. Put a point anywhere you want. We're going to just draw a point. Got me? So we're just going to put a point there. Good. We're going to move our compass down now. And just like before, we're going to draw one of those big arcs. We're going to draw an arc from here to here. Okay? Got me? Okay. Now, what we're going to do, we're going to put another point on our paper. Alright? Pretty much across from our point, like over here. Doesn't matter where you put it on the arc, but you're going to put it on the arc across from it. And this point, we're now going to use to draw our other line. So we're going to go over here, flip over our compass, and we're going to draw another line. Okay? So we're just going to put it on this new point, and draw it across again. Alright. So those are your two. So just to go back, you draw your point, you drew an arc, you put your compass on the other point, draw another arc, and now all you have to do is draw your lines, okay? So, put your compass away, just take out a protractor and connect your points. Alright, we got a point up here, and we have our two other points, and we're just going to connect them with lines. So we're going to take our line to this point, to this point. And that is all you need to do. Alright guys, that's it for this lesson. You are all amazing, bright, shining stars, and don't actually eat a star. It hurts.